Yeah.
Okay, I'll share my screen. So today we are going to discuss that how do we decide if two requests are concurrent or causal, and if the two requests are concurrent, how does a database handle them? And then we will discuss about version vectors. So let's discuss these three things one by one. Can everyone see my screen?
Yes.
Okay, cool. So I'll use my mouse pointer and then we can follow it. Okay, so first problem, how do we know that two requests are concurrent versus causal request? So concurrent means for a database, they happened at the same time. Database does not know which happened first, which happened later. Causal means happened before, that we know that this request happened after this second request. So let's see an example and then we can discuss in more detail that what is the meaning of each one of these. So let's first look at the right side. So let's say I have a shopping cart in my database and there are two clients simultaneously updating the shopping cart, right? And so initially, when I read, I see that the shopping cart is empty. I add milk to the shopping cart in the database. Database writes milk. Then another, my friend, my wife, she also reads the cart. She sees it has milk. So now she updates it with milk and eggs and then writes this to the database. So now the database will have milk and eggs, right? So here, my wife knew the about the state of the database, and her request happened after my request. So these two requests are causally, and in the case of causal, we can simply override because this other person had the knowledge of the previous person's request. He knew what he did, so now whatever decision he's taking, we will respect his decision and override with whatever value he or she wants, right? But let's look at the other example where uh, both of the clients, they read the card, they saw empty, and now, and maybe it's not at the same time. So this person read the card at this time, this person read the card at this particular time, right? But now they're updating it. One person added milk, other person added eggs, and these two requests are concurrent because none of us know that we have added something to an empty cart at the same time, right? In this situation, we have to decide how the database should handle it, whether it should overwrite each other's request, it should merge them, it should succeed or fail, right? So basically, yeah, so this is the difference, and now we'll see like what do we have to do. So this case is simple, we will simply overwrite. The complex cases, what should we do when the two requests are concurrent? So there are three possible things that we can do when two requests are concurrent. So one thing we can do is we can keep one and return failure for the another. So we will take only one of the values, and to other client we will respond with failure, right? And the way to do is, we have discussed before, either we can use optimistic locks or pessimistic locks. Optimistic locks are cast, compare, and set. So basically, both will be allowed to write, and if we will see that the value of the database has changed to what the value was read, then one of them will be failed. And this is like each one will have to take locks on the database, and only once they acquire the lock, they are allowed to make the update on that row of the database, right? The second approach we have is last write wins. So in last write wins, what we will do is we will return succeed to both of them, but we will keep the value of only one of the person. So we will return success to her, we will return success to him, but we will keep only the last one, which is milk, right? in this case, it's a data loss because we are only keeping one of the person's value and we have returned him success, although we have not kept her value. So she got success that her eggs were filled in the basket, but still uh, we have removed her value and taken only one of the values. The third option that we have is that we can merge both of the values. So when we see that the two requests are concurrent, I can merge and maybe create a basket of milk and eggs and merge them, right? So these are the three things that can happen. So one thing I want to mention is this first part where we take one and return failure to other. This is only possible in single leader, right? Why is it possible in single leader? Can anyone tell why it is not possible in other multi-leader or leaderless?
In multi-leader case, we cannot lock two at a time, right? Two leaders locking is not possible. That is for the pessimistic. And also in the multi-leader case, we would not know. I mean, like the right might go to like different places, right?
Yeah, exactly. Yeah. So basically, in single leader, we are saying that one of the person is only the decision taker and he only has the authority. So all the rights will go to him. So he can check whether to succeed or fail this right. If they happen concurrently, I can take one and reject other. But in leaderless and multi-leaders, those two or three of the databases are leader. So each one of them will individually think that I got the request first, I got the request first. It will succeed them, right? Because it is its own leader. And now it does not know like uh, what happened. So it cannot fail because I have already returned success to client. I saw my database, I saw this value was fine, others saw its database, he saw the value was fine, he returned success. Now when I'm doing the sync between the two database, now I found out that these two requests were concurrent. So by this time I have already returned success to the customer. So that's why this thing is not possible in multi-leader, right? So in multi-leader or leaderless, that's why we have these two options, that either we will take last right wins or we will do merge. This last right wins, frankly I cannot think of any situation why we will do that. Like merge seems meaningful uh, because basically you are losing the data. But I was reading the book, and in the book it said that the Cassandra by default it uses last right wins.
Actually, I felt like that was okay because when you have multiple users updating a single value, right? It's like we would we care like about the intermediate states? Like if there is one record that I'm updating saying that uh, let's assume the price of this item is $10, and there are like multiple users updating it. So, and when you allow multiple users to update it, if somebody sends 10, somebody sends 20, and as a system, we received 20 as the latest, though 10 was the latest. If we lose the 10, that's still fine, right? Because I mean, like the user who is updating also doesn't expect that the value will be so, because it is available for other users also update. So he made it 10, but since it's available for other users also to update, the value could change.
Yeah.
That's kind of an expected in some cases, I believe.
Yeah, in some cases where, yeah, where you don't, where the expectation is that like something like bidding or something, yeah, where you are saying, okay, the last, whoever is the last,
Yeah.
that will win, and the system can make the decision. In those cases, yeah, it
And
makes sense. Yeah,
users are aware that this is available for multiple users to update. So
yeah, yeah,
they cannot be, yeah. So we use similar kind of thing. That's the reason I was telling that.
yeah, yeah. Okay, yeah, makes sense. Yeah.
I mean, like we used it using merge instead of system doing that. We maintained both the files and we merged it in the backend by taking the latest one.
Okay, okay.
So I think we discussed in one of the sessions earlier. Yeah.
Yeah, yeah.
Yeah.
Okay, cool. So yep, should we move on? Anything else? Okay, one another thing I want to add is, so basically in the first approach, right? First approach, one issue is that we have only single leader, right? So basically our writes will have low availability because they can only go through single leader. And also you can see availability is low in this sense that we are returning success to one, failure to another. So the person to whom we have returned failure, we were not available to write his data, right? So in that way also the availability is low. Whereas these multi-leader, leaderless databases, their main goal is to achieve high availability and eventual consistency. So what they are saying is that whatever right you are giving me, I will take that right. I will never say no to you. Every time you will give me right, I will say I will take it. So one of them, it will just keep the latest. Another approach is it will take both of the rights and then eventually it will try to merge them and conclude on one single value of that item, right? So okay, so now let's go and see how this happens in action. So basically,
One more thing I want to add was so the last rate when may not be actually last rate actually. So there can be two requests that are coming to the multi-leader or leaderless at the same time. So the each database might have its own logic to merge those.
so you're talking about concurrent, right? And
Yeah,
by
concurrent. Yeah.
concurrent, so concurrent means it could happen at the same time or it's happening at different times also, but they don't know, like they saw this also saw empty, this also saw empty, and now they made the request. So when I don't know about you, what you were doing, and now both of them did something, then those two requests are concurrent. But if I had the knowledge of what operation you have did, and now as a result of what you have did, now I'm making a change, then it is like happened after. My request happened after your request.
Yeah, so I was actually trying to say the same thing. Like, hey, you have kept one single line, right, at the cart.
Mm-hmm.
So that may be one server or two servers. So so one of the requests might go to one server and second request might go to same server at the same time. So there's a gap between these two requests, right? I'm saying they might actually end up at the same time, even in seconds or milliseconds, something like that as well. I'm trying to say that they might reach the servers at the same time.
So, so I just want to understand. So, are you talking about single data, single server or
No,
multi
no,
server?
not single server.
Uh-huh.
The multi-leader or leaderless.
Okay. So, in multi-leader or leaderless, let's say we have two databases, then.
So there are two requests. One of them is ending up at machine one, and other is ending up at machine two,
Yeah.
and they might end up at the same time. I'm trying to say that.
Okay.
Even
Yeah.
in
And
milliseconds, sometimes it may happen that even in to the at most precision, they might end up at the same time.
yeah, I got you. Okay. And even if, yeah, they can happen at the same time, then these two requests are concurrent. Yeah, totally right. Or even if they happened at some interval also, but this database did not know about this request, then also we will consider it concurrent, right? So yeah,
Yeah.
you're right. And we will discuss more about it when we will go to version vector, that how this has happened in multi databases. But yeah, that's
No,
correct.
no, I was just trying to tell that in the last write win, I mean, for every database, there will be a last write win plus another. If last write win is that one action, it might fail here, right? So database will have another constraint as well. In
Oh,
terms
okay.
of Cassandra, it takes as what it considers the data as a blob. So whatever is the lexicographically largest, it will take. It will pick either of that.
Okay, okay.
Uh, so the last time is both of the records are the same itself.
Oh, right, right. Okay, I got your point. You're saying if they happened at the same time, then we don't know that which one is the last, right? And
Yeah.
okay, so then they will, so database has some logic that maybe it will give
Yeah.
preference to one of the databases or something, right?
Yeah.
It
Okay.
gives preference to one of the data entry or the database?
Data entry.
Data entry.
Yeah,
Oh,
actually, no. What you have said is also correct. There are, I mean, different methods that were taken by various databases. So there is a priority concept as well. That is in some of the systems as well. So every node will have a different ID, and if if that request ends up at a higher priority node, that request will have a higher priority to end up finally.
Yeah.
That that way is also adopted by some of the systems.
okay. But I think we should also take care of data entry also probably, right? Because that could happen on a single machine as well. Exact same time. Can that happen
Uh,
at all?
may not be because there is a queue of requests.
Hmm.
Even if it ends up at the same time,
Yeah.
if they are writing to the same key, there might be locking and these all compare and set as uh, Abhishek was saying. They, I mean, generally you will end up, if it is a single ladle, you will have locks and these also. That might not be probable, even if it's having, even if you are doing it in multi-threaded way.
Let's assume if it is a multi-leader thing, but the request can go to the same server. And since we are not following locking or anything, it
Oh,
go
So
almost at the
you're saying
same.
something like this, right? Two requests came at the same time on one database, right?
Yeah, yeah.
So yeah, in this
Wondering if
case,
that.
what who was talking right now? Sorry, what's your name?
Uday.
Uday. Yeah. So what Uday was saying is that database has their queue, right? So even if they happen at the same time, like database will like pick one first, or it can apply lock or whatever. If they don't have locks, then it will just in the queue it will keep one request first, second later, and then process them one by one.
Okay, they could have. I mean, like, it depends on the database implementation, and they would generally have queues, is what
Yeah.
we
Yeah.
are thinking. Okay.
Right, Uday?
Yeah.
Yeah.
Okay.
Okay. So okay. Hmm. Okay, so now let's go to uh, so now let's see, like, on a single database, how does a database knows that whether two requests uh, they have a happened before relationship or they happened concurrently at the same time, right? So let's take this example again. So let's say we had a shopping cart and it was empty. We are at V0. So client 1 and client 2, they will read the value. We know that it's V0 empty card. This is V0 empty card. I will add milk to it. So when I'm adding, so the main thing I have to do is whenever I'm making any modification, first I have to read the value and know what is the version. So I know this is the version. And when I'm sending an update, then I'm also including what was the version I read. So I read V0, I will send this to the database and I'm saying I'm updating it to milk. So now the database will see that the version which I was sent by this client is equivalent to the version I have in the system. So at this point, the version in the database was V0, right? So because it is equivalent, the database will update. It will respect whatever the client is saying. It will update it to V1 as milk. Now, in the same time, in this time, what happened was another person also read the value, and by this time the cart is still V0 empty, and now he added eggs to it, and now I'm sending that V0 is what I have read. Now when this reaches the database will see that the version which the client has sent is lesser than the version which I have right now. My version is V1, right? So that means the client was not aware of the change to the database. Client had a previous value, stale value. So now it knows that these two requests happen concurrently at the same time. So now database will apply some merge logic or something, and it will keep both the values milk and this new value eggs, and it will always increment its version. So now the version is v2, right? So yep.
Sorry, what if it is the same value, right? It's not an append kind of thing.
If it is the same value, yeah. So basically, if it's an empty cart, right, and you are saying that it's the same value, one person has said milk, one person had said eggs. So now we are discussing that merge, like how should the merge happen? So basically the merge logics are like this: either the database will keep both the values and append them, or database can say store both the values and say that from client 1 I had this value, client 2 I had this value. So when the client is reading it, client can see that these are the multiple values I have got, and now the client can decide how to merge them. One approach is that the database is merging for you some logic. Other is that database will give you all the values it has seen. So your question is like the same value is updated to 2, right? So let's say if the scenario was that can I attend the birthday party, right?
Yeah.
And one is saying yes, one is saying no, right? And now for this scenario, the database does not know how to merge them, yes or no. So either the database can have its own logic that if it is yes or no, I will put the value as maybe and store it like this. Or the other approach is when the client is reading this value, can I attend the birthday session? Database will return this, that one has said yes, one has said no. Now you take the decision. I don't know. I have saved both the values for you. Nothing is lost. You take the decision and let me know how should I update it.
But who will take the decision? Because if you say the client will make a decision, wouldn't that you mean like send that to all the client?
So by
so they can make a decision,
client,
or only will
I
send
mean,
to one single client?
yeah. So by client here, I mean the applications server. Basically, these are the applications servers, right? Which are talking to the database, and these are sending values. So the application servers will have their logic, right? Here for the database, these application servers are client.
So don't need to send a client 1, only send to client 2 to make that decision.
Whoever is reading. So on read, whenever someone is reading the value, then on the read, I will store everything and return those value. Whoever is reading, if client 1 is reading client 2, and once, so the client 2 has read the v2 of this thing and it has merged. Let's say it merged and said that I want to store no, or I want to store maybe. Then it will send me an update with v2 and I will save this value.
Was this discussed in the book, Abhishek? I saw this example, but I was not sure if I followed it, like about updating the same value and client taking the action on it.
Yes, so this is discussed in multi-leader replication. In multi-leader replication, he said that if 2 of the values are updated at the same time in different leaders, now we have to merge. So there are multiple approaches to merge. And basically this CRDTs and operational transformations, these are all approaches to merge, right? How should we merge the values? So
okay, good. And again here, like when we say client maintains the version, I'm assuming it's like it's not the, if suppose I logged in using my browser, so would the login user have versions? Or, yeah.
No, I mean that this is the application server which will have that logic, and so you don't have to maintain a version or something on your end. What I'm asking you is that whenever you are updating a value, read first, read whatever version you saw, and then on the write request, send me whatever version you have read. So,
okay.
so I'm reading. So it's similar to e-tag, right? In e-tag, like you are first, I don't know if you guys know about e-tag or something, but you are reading the value and then while write, you are specifying the e-tag. But in e-tag, it is just it's for a single leader that either it will accept or it will fail. If the e-tag does not match, it will fail, right? Here, with versioning, what we are doing is we will not just succeed or fail. If we know that your request was concurrent, like your e-tag does not match, then I will do something to merge the values. So that's why we are using this versioning thing to know that if something happened at the same time with the versions, then I will merge the value.
Yeah, so I was thinking like each client will have its own version maintained and everything has to be maintained on server, but
yeah, you don't.
Anytime, yeah, it's the number of versions in the server, that many e-tags will be maintained.
In the this versioning thing is maintained at the database, but to the client it has to just read that version whenever it is going to make a write request.
So from safer side, each client have to read, just like in e-tag, client after any update, client should match the version that whatever version he has read from and whatever the newest version he is putting into the database. Like client 2 has a dead version v0, but when it's putting it's a v2, so means there is some in between. Client 2 can say that something.
No, so okay, so basically, yeah, let's go over this first. So what this client 2 is doing is client 2 is reading the value of the card, and also the database will return version. So database is at v0, it will return version and it will return the value, right? All I'm asking client is that whatever updated value you want to send, update it so the value is updated eggs, and also send me whatever value you have read. So I have read v0, so and I will only do, my work is only this, I will send you v0 eggs and I will send this to database. Now this green part is everything which is black is what the client is doing here, the green part is what database is doing. So now the database saw that my version was v1 and the client has sent me a v0. So that means the client had stale value because he read the value at this point and someone has already updated me at v1, so he has a stale value. So that's why I will, two request has happened at the concurrent time, the client will decide that, the database will decide that, and so the database will merge these two values, and then database will say now I have v2 version of the data. So database will always keep on incrementing. So here it was v0, v1, v2, it will keep on incrementing. Was that your question or were you asking something else?
No, actually, yeah, that's also worse. I was thinking of this logic should be at the client end, but yeah, that should be at the server end. Server should database has to maintain this relationship between vectors.
Yeah, this vector logic database will maintain, but the client can have this logic that now, let's say this value is saved, right? Now, if I'm reading the v2, so the database, what it can say is I will not merge or something. I will say that, that the, like for this cart, like from client 1 I got the value milk, from client 2 I got value x, and I don't know how to merge this, I'm just storing it as it is. So now when the client 2 will read the value, it will return v2 is what, and the value is milk and cart. So I think there are some data structures and all to store this kind of data. So the database will return this thing, and now we can also leave this logic on client, how to merge these values and how to update it with the new value.
So before the client they write or update the card, they seem like they don't need to read it first before they write it, right?
Yes, yes.
Because in some case I do see they read it first, like for v0, They have to read it first before they write it. But then for V1, they don't read it. They just update it.
So here, if you're saying, are you saying here?
Yeah, right there. They
So
don't read it. You just go ahead and update it, and
No,
you know,
so
let the
here-
database take care of it.
Here, what we're saying is the value which I have read is basically the last which was returned. So this is the value I have read, V1 milk. Because I have to send the version, so I have to read the value. And that read could be either a explicit read, or I can say that whatever was the success of my last request, in the success, whatever is the version and information that the database has returned, that I could treat as my read.
Okay. So before it write, it does not have to read from the database. It just, you know, whatever. Let's say, you know, they have V1 for a while, and then, you know, and then now it wants to update the database. It still use V1 to update it.
Yeah, I mean, yeah, you can say that here the database is not, I will say it's kind of a read, but yeah, you can say it's not explicit read. Whatever information I had last known of the database, I'm sending that value. So, yeah.
That information could be stale, right?
Yeah.
Okay.
Okay, so we were up till here, right? So it returned okay. And then here we will see at the similar time, the information I had was V1 of the milk, and I'm using that information to update the database with milk and flour, right? So I will send that the information which I had is V1, and I want to update it to the milk and flour. Again, the database will see that my version is V2, right? Before this point, when the request hit, before this point, my version is V2, which is more than the version which client is sending. So the client has a stale value, right? So these requests will be treated as concurrent request, and again it will merge. So it will keep V3, it will save one value as milk flour, other value as eggs, right? And it will store this value. Now, let's say another simple scenario is, now the client reads this, it reads V3 milk flour eggs, and now it updates the cart to just milk flour bread, right? So now it is sending V3, and I also see that the version which I have in the database is V3, means the client has up-to-date information. So I will just overwrite it, and the V4 will be milk flour and bread, right? So this is like happened after. This happened after. So in happened after, I will just override the values. And how we know happened after is, if the version of the client is equivalent or more than the version of the database, then it happened after. But if the version of the client is less than the version of the database, then we know it's a stale value, and like two clients might have updated the value, and they have been a concurrent request. So that's why I will merge the values.
Could you repeat that again? The happen. So
Yeah,
the client is V3, and then
Yeah.
they send to the database, and the database is also V3. So they
Yeah.
match the version, right?
Yeah, so they match the version. So it means that the client has up-to-date information. So I will just overwrite with whatever the client has sent. So if the client version is greater than equal to server version, then it is like, it is a causal relationship, and I will just overwrite. But if the client's version is less than the server version, then database will treat it as concurrent, right? So in these cases, right, you saw that the client version V0 was less than the version on server. So that's why it was treated as concurrent request, and it merged them. But here, the client version was V3. The version which I have is also V3. So it is equivalent. So that's why I can just overwrite, because I know the client has up-to-date information. Client has seen me in the up-to-date state. So now whatever decision he's taking, he's aware of my state, and being aware, he has taken the decision. So I will respect his decision and just update the database to whatever he's saying. But the only thing is, I don't want to do anything for the client for which he was not aware of. So at this point, he was not aware of this state. He was only aware of up till this point. He was not aware of this point. So I don't want to overwrite or do something. I'm saying that, hey, you were not aware of this other part of the database which someone else has updated. So I'm saving this for you, this also for you. I'm saving your value for you. And now we can decide, either you can give it to me to merge the values, or I will merge it for you. Okay, if this seems fine, then we can move to version vectors. So basically, version vector is, this was a simplified version where we have only one database. Now, when we have multiple database, basically we are talking about this, how this happens in multi-leader and leaderless databases, right? So how this approach is maintained, how this versioning is maintained. That is basically version vectors. Should we move on? I think no one has questions, so let's move on. So basically, with version vectors, what we are doing is, so here, because we had only one database, so we were storing that database version of information of that item, right? Now, in the case of multiple databases, we will store a vector. So a vector will represent that what is the version in each of the databases. So let's say I had database replica 1, database replica 2. So this first index will represent the version in the database 1. The second index represents the version in database replica 2, right? So, and similarly, how many database replicas I have, I will need to have the vector of that many values. If there are 5 replicas, I will have this kind of array of 5 versions. So that's why it's a version vector, right? So now how this thing is handled. So let's say initially both the replicas are in sync. They have 0, 0, 0, 0 as the version, right? Now, let's say this database replica 1, it got 5 new updates from the client, right? So whenever it will get an update, it will update its version vector. It will not update other one's version vector. This is what he has last seen and what is the information he has from the other database. So I'm saying that by this point, he has not talked to other database. He only got 5 requests from the client. So he will update its version to v5, and this is 0, right? And during the same time, this database has not got any updates. So there were no new updates on this database. So for this is 0, 0, right? Now, when they sync, when they have to do sync across each other, I will see that looking at these values, I can see that the database 2 has not got any updates, right? And the database has 5 updates, right? So that means the updates on this one happened after, and so I will just sync them. I will, whatever are the updates, I will apply to this database also, and I will say now they both are in sync, 5, 5 and 5, 5, right? Now let's take this another scenario where there were 3 new updates on this database, so its version incremented to 8, and there was one new update on this database, so its increment happened to 6, right? Now if I'm syncing, now I will see that there has some update happened on this also, there has some update happened on this also. So that means these 2 requests happen concurrently. So now I would have to merge the values, and whatever the merging logic we have, we will have to merge it. So in this case, I can just overwrite it and I can save the value of whatever was the replica 1, but here I will have to do merge because both of them have got the updates. Right, so this is, yeah, so basically this is how the version vectors are.
And the merging logic is based on latest version that was discussed earlier, right? Same kind of.
Merging logic could be anything, yeah. So either it could be just merge the values, it could be, you know, operational transformation or CRDTs. Yeah, so that depends on the database.
Yeah.
Or yeah.
So this one we talk about, you know, the same, we updating the same data in the database, right?
Yeah.
And you know, how do we know if it updating different data in the database?
Yeah,
and there's no conflict.
Yeah, that's a very good question. So this version vector is maintained for each item. So each item will have its own version vector. So you are going to use the version vector of that item. So that item too will have its own independent version vector. And so when you are doing a merge, then you are looking at the same items version vectors to compare. And so that's why you can see that this version vector, if there are, you know, like 15 to 20 databases, and probably won't have 15 to 20, but let's say if you have 4 to 5 databases, for each item you are maintaining this vector of 5, right, for each of the replicas. So I think there are other approaches, dotted version vector and all, which tries to compress this data. And I don't know exactly deeply, but there are research papers and all that how to efficiently store this thing for each item and then send it across to do the sync.
Item means each row, right?
Each row, yes. So for each row you have to maintain this version. So if anyone has book, yeah, you can see that he specifically says that for each item you will maintain this version vector.
And
that would be a lot, right?
Yeah, and yeah, that would be a lot, and that's why. So this was the basic idea, but then there are this research and all on this, which is dotted version vectors and all, which tries to compress this information.
These versions are at the database or the versions at the client?
So this information is stored at the database for each item when the client is reading. So if I'm reading item 1, right? So let's say this was item 1, and let's say for item 2, the version vector was 5, 6, right? So whenever the client is reading, so again the same logic applies. I'm saying that whenever you are updating me, first you have to read the value. So when he will read the value, I will return him this version vector, entire version vector 0, 0. And now whenever he's making the update, he will have to specify me that entire version vector.
So let's say there are 2 clients and they have read that version vector. Let's say initially it is 0, 0 itself. Now there are 2 clients, they have read at the same time, and they replied back. They replied back with their update. So what would happen here?
Yeah. So so let's take this example. So there were 2 databases, right? DB1, DB2. There are 2 clients, C1, C2. And so basically, initially we are saying that both has version vector 0, 0. I read the value 0, 0, 0, 0, and now I update it to something, right? So I will let's say the value was x is equal to 5. I'm updating it to x equals to 7, right? Let's not take this example because it's hard to merge these values. Let's say the cart was empty and I'm adding milk to it, right? Okay, so now he will send me this version vector 0, 0. So when this request come to me, I will update my own version vector, and because there has no sync happened yet, I will store this as 0 and I will store the value of cart as milk, right? Now this client, let's say this updates the value to eggs. So I will update my version vector 0, 1, and I will store this information x, right? Now, this is what has happened so far. Now, if the merge will happen between these two, then I will see that I have also got some new updates and he has also got some new updates, right? So I will do a merge, and basically I will, and let's say if it is a just append everything. So then during the sync, I will store the value as milk eggs, and now the version is 1, 1. Both are sync, and this will also be 1, 1, and milk and eggs.
So
So-
I was actually,
Mhm.
this is if requests are coming to two databases, right?
Hmm.
So I was actually referring to if they come to the same database, something like that.
So that is everything is what we have discussed, right? If it's on a single database, if two requests are happening, then everything you can apply, whatever is the logic. So on a single database also same thing, that if the version what I have read is, so basically I can repeat it, or basically let's say the first one got 1, 0, right? And now let's say I'm sending this information to this here eggs, right? So it will see that the version which he has sent 0 is less than the version which I have right now 1. So that means these two clients have updated me concurrently. So here I will do a merge and store the value as 1, 0 and milk eggs,
Okay.
right?
Actually, okay, sure. So
So yeah, let's do it. Probably we'll find some issue and then we can discuss. So let's say up till now the sync has not happened. So the two values, so basically this has sent me version 0, 0. My version is, the request was 0, 0 and eggs, right? So I will
no,
see.
this will work up. Got it.
I'm so sorry, what?
No, I think this will work up. I got it.
Okay, yeah.
So
Yeah, here the version vector, the first digit is representing the updates, and the second digit is representing the total number of syncs.
No. So
Hmm.
each digit is the version vector of that database. So this is the, so whatever I said, this versioning on single, right? So this is the versioning of DB1 and this is the versioning of DB2. And
Okay.
and basically for this, for me, this value is what is the known information I have for DB2. So for DB2, the last sync I had is I have seen him till version 0. I have yet not updated from him,
Okay, got it.
right? So that's why when this eggs was updated, I have updated my version vector 1 because this is the version vector for me. And the last known I have seen from him is 0. Whenever they will do a sync, then at sync, then I will store the latest version vector of both because I have seen the latest value from these two. So then it will become 1, 1, right? So like here we discussed when they had a sync, then I have seen the latest value from this. So I will store 5, 5 because this has also seen the latest value and this also has seen the latest value.
So here we are compromising on the consistency, right? Up here.
We are, no, how are we compromising on consistency? Like we will we will eventually merge all the values. Basically, our goal is that no data should be lost. And so overall, the goal of this problem is that if we should know if one request happened after another, that means that this request had the knowledge of previous request. So I will respect it and overwrite whatever the value is. Then I'm not doing any data loss because he had the information. But if two requests has happened concurrently, my overall system should not lose any information. It should store all that information. It should merge it or do whatever, but it should store it. So this is what we are trying to achieve, right?
Yeah. I mean, eventual consistency, right?
Yeah, eventual consistency.
Because between the things, the client could read and it could go to, though he has written something, it could go to wrong server. I mean, the other server, and he could get a wrong, different value. But once the sync completes, he would get the latest value.
Yeah.
Right. So that.
So on that note, I think we are kind of on time, but just a quick question there on eventual consistency. So can't we use that idea of quorums, like to ensure that at least one read that we have is the latest one, even though all the, replicas are not in sync? Can that idea be also used here? Like we've talked about this write quorum and read quorum, right? If there is an overlap.
Yeah, so the goal of quorum is that what should I do with the writes? Should they be successful or failure? So
I'm talking about what Naga was pointing to, right? That if it's eventual consistent, if I hit a server which is like where my request was written and the read server is different, then like Naga was pointing that I may get a stale value, but eventually they'll all sync.
Oh, right. Okay, yeah. For that,
I'm saying to avoid getting the stale value, maybe we can use that quorum idea.
Yeah.
Mm-hmm. Okay. Yeah.
Okay.
Yeah, like you were saying, distributed system, you solve a problem, there is another problem.
Okay.
Okay. So
like on time, but any last questions? Okay. We have folks from the next session. They have joined. So thanks, Abhishek. This was great. I will stop the recording.
Yep, this is great. Thanks, Abhishek.
Yeah, thanks.